Ramlik, unmute yourself.
Okay, I hope you can hear me. I'm back. Okay. Can you hear me? Can you hear me?
Yes, ma'am.
Can you hear me? Somebody should respond.
Yes, ma'am.
Yes, ma'am, we can hear you.
Yes, ma'am, we can hear you.
Can you hear me?
Yes, ma'am.
Okay. I hope we are recording this lecture. Okay. So we talk about the environmental geophysics. That is the application of the geophysical methods to the investigation of the surface, these chemical phenomena which are likely to have significant indications for the management of the local environment. So I said I use the oil spillage from and to get contaminated and map this extent of contamination. So applied geophysics covers everything from experiments to determine the thickness of the crust, which is important in the carbon exploration, studies for engineering site investigation, exploring for groundwater, exploring for mineral narrow mines, other forms of buried cavities. Likewise, you can have underground reservoir. We can have buried parts. You can have ammunitions, and you want to locate where they are. Okay, leaking pipes. Our geophysical methods can help us to identify these locations where we have these buried ammunitions. Maybe they've forgotten where they bury it. You have leaking pipes, you don't know, you can use it even for forensic studies. For instance, indiscriminate burying of bodies, and you want to identify where the corpse is, you can use geophysical method. That's forensic geophysics, and it can help you to delineate, to identify the region where a body has been buried, and it can help you to identify the location. So it can also help in that area. Archaeogeophysics, where you have remains of buried body, it can help us to map it. Hydrogeophysics, there are some locations where they don't have potable water. They have a failed borehole. They have drilled one borehole and they discover that the borehole is seasonal. Maybe during rainy season, they are able to get water. Dry season, no water. Okay. And geophysical methods can help us to identify the aquifer. When you talk about the aquifer is a formation that has the capability to store fuel and transmit, also determine the thickness of this aquifer. You can see maybe at a particular depth, the thickness is so small. Since the thickness is small, the volume of water that you can be able to explore from the aquifer might not be large enough to meet the demand of those in that compound. As a result, the rate of this recharge is not the rate that is being used. So they'll always have a problem of of insufficient supply of water. And you're able to when you're able to identify like 3, 5 so, so we talk about the hydrogeophysics in groundwater. So I said, so if you are able to carry out the investigation, you're able to see the thickness, and that we're able to meet the demand in that. Talk about the glacial environment when you have the ice. Okay, so this is a seismic section, and I told you for your seismic method that we have seismic reflection and we have seismic refraction. That the refraction is for shallow investigation, while your reflection is for deep investigation. That is usually hydrocarbon exploration. And you look at the depth being investigated there, you can say about 2.3 kilometers. Okay, 2.3 kilometers. So that tells you that it's deep. Okay, for you to be able to probe up to 2,300 meters down the subsurface. So you have your active source, you have your source. You send your signal into the subsurface.
So are all the banks? Why are
Which
they
will
all
be a
putting outside their bank? What's going on? Is it
vibrosis, generic energy is being detonated. So this acoustic energy makes me stop disturbing my class. You just joined and you're disturbing class. Okay. So you have your active source, which will be your dynamite or your vibrosis. Your vibrosis is good because you can control the rate at which the energy is being detonated. Okay, now this energy is being detonated and it propagates into the subsurface. So you can see the energy being detonated and it strikes a lithologic boundary. Once it strikes a lithologic boundary, what happens? It gets reflected, which are the geophones here. Our geophones here are the receiver here. Okay, so when it is on land, we have the geophones. When it is marine environment, we have the hydrophones. So when the energy is and it gets
Oh, yeah, thank you.
microphones in water that measures the pressure difference. Okay, so what it records is the arrival time. What based on the principle of the echo sounder, just like you said, your signal, you project your sound, and when it strikes the wall, determine the depth. Okay, to the subsurface. Then we also make use of our airborne platform. We can use that also to use method to identify the area of anomaly. We don't know where the target is. In the rest of the ecosystem, okay? You carry out your reconnaissance survey, and that helps us to identify the area of anomaly. Okay, we now identify that where we have the accommodation is in faculty of science. Okay, so once we have identified that it is faculty of science, we can now carry out our detailed investigation using a contact method. An example of the contact method is our electrical method, assessment method, that will give us detailed information for the refraction method. You can say that the depth of investigation is not deep, okay? And you have different sources. For your dynamite, for your fibrosis, you use that for deep investigation. But you want to use a sledgehammer on a metallic plate. You just strike your sledgehammer on metallic plate to generate acoustic energy. You can imagine to what depth will the acoustic energy be transmitted before it gets attenuated. Okay, it cannot travel so far. So this kind of source is used for shallow investigation. Okay, you want to investigate to determine how competent the layers are for proposed structure. That is engineering investigation. Or you want to use it to determine the depth to the aquifer. Okay, we can also use this kind of method for groundwater investigation because those are near surface investigation. And what parameters do you measure? Contrast, variation in the density, variation in the propagating velocity of this acoustic energy in the subsurface. Okay, when it is being transmitted in medium 1 and medium 2, what are these contrasts in these values? I told you that as you travel deeper, the density increases. Likewise, as you change from one medium to another medium, the rate of propagation also changes depending on this variation in the physical properties of the materials at the surface. So when you talk about seismic method, what do? It has to do with transfer of energy from one point to another. And basically, we talk about two types of energy, seismic waves. We talk about the body waves and the surface waves. So when you talk about the body waves, they travel through the interior of the earth. But when you talk about the surface waves, they travel along the surface. So for the body waves, we have the compressional wave velocity and we have the shear wave velocity. And for the surface waves, we have the railing wave, we have the log wave, and we have the Stoney wave. So when we generate our seismic section from our seismic method, what do we want to identify? We want to identify the continuity of the sand. We want to know if there's any discontinuity, maybe there's any fault. Is there any immunogenities that can guide us? Okay, this is the seismic section from the seismic data acquired. This is a section being generated. Okay, and from there, we can be able to identify the faults that we have here, the structural features that we have. And these structural features could be associated with hydrocarbon accumulation. It could be associated with mineral deposits. So when we interpret, it can guide us in identifying these minerals that are deposited at the subsurface. So these are some of the structures, faults that help in trapping hydrocarbon accumulations in the Niger Delta. So the seismic can help us to identify geologic conditions favorable to accumulation of hydrocarbon. It can enable us to identify map horizons, faults, delineate reservoirs before drilling commences. When you acquire this data, okay, for instance, like I said, let's say we have acquired our seismic data and we have identified some structures that indicate that we might have hydrocarbon accumulation here. Then what do? It gives us clue of where to drill. We now want to drill a well to confirm, is there truly hydrocarbon at that spot? Okay, so that is drilling. So it gives us idea of where to drill to confirm the presence of hydrocarbon. So when that's been confirmed, another thing is, what is the quantity that we have there? Okay, so we have what is called appraisal well. We have what is called exploratory well. We have what is known as production well. Exploratory well, that is when you're still searching the white cat, the first well that you drill to confirm the presence of the hydrocarbon. Then you have your appraisal well, when it starts determining parameters to know the quantity of hydrocarbon in place. Does it worth exploring? What you are going to explore? Are we going to make from it? Does it really worth investing in? So those are the things that we also have to put into consideration. So it helps us to delineate the hydrocarbon reservoirs before drilling commences. It enables us to locate the optimum location, that will enable us to enhance our hydrocarbon production. Okay, so it determines reservoir quality using seismic attributes. And it can also help us to monitor our wells. Even when we have started production, seismic method could be used to monitor how the hydrocarbon is being produced from one production cycle to another. And when you even want to acquire your seismic data, we have two types of profiling. It could be horizontal profiling, it could be vertical profiling. Horizontal profiling in the sense that your source, your receiver, they lie on the surface, okay? But when you talk about the vertical seismic profiling, you have your source at the surface, but you have your receiver being placed in the well and information recorded. And we have different types of vertical seismic profiling. We have the offsets, we have the near offsets vertical seismic profiling, we have the walk away vertical seismic profiling. Now, when you talk about geophysical investigation, we have 3 stages involved. First, data measurement. That's data acquisition. Go to the field and acquire your data. After acquiring your data, you have to process that data. That's data processing. Okay, so data acquisition is there. The second stage is data processing. After processing your data, you now interpret. That is interpretation. So you can see 3 stages. And when you want to acquire your data, you can acquire your data anywhere. It could be on land, water, air, through use of also the advantage of environmental friendly. You don't have to remove anything. Just take equipment that you take your equipment, take measurement. Nothing will be tampered. So it is environmental friendly. It is cost effective. It is relatively cheap. Okay. So, but in that we have contact method and the non-contact method. Using one platform now, you don't need so many there for you to be able to acquire your data. All you just need to do is to attach your equipment and the measurements are taken. But for the contact method, you have to be there. For instance, electrical method, your seismic method, you might need up to like 3-4 personnel to work with you on the field to acquire the data. Okay. So another thing is that interpretation is non-unique in the sense that you can mean so many things, okay? But when you interpret, when you use 2 or more methods, and the 2 methods they agree that this is what is happening, that is when you have confidence in your interpretation. Okay. For instance, I asked, can we have class today? Somebody told me that you'll be having test you'll be having test 11 o'clock. Another person also told me that you'll be having test 11 o'clock. That means there is correlation in what they are saying. That means that is correct. That is most likely that they have test for 11 o'clock. But for instance, one is telling me that they have test for 9 o'clock. Another one is telling me that I have test for 11 o'clock. That means they are not agreeing. So I will not be able to judge my decision based on that information. That means I will need a 3rd person to confirm that information. Okay, so likewise, when you talk about geophysical methods, we don't just interpret in isolation. You use one method and you base your judgment on that method. No, you use 2 or more methods. And when the 2 methods, 3 methods agree, telling you that this is most likely working here, then you now use your borehole information to further confirm your interpretation. That is what will give us confidence in your interpretation, that you have validated your results, you know what you are doing, and what you are interpreting is correct. So when we talk about geophysical methods, we can classify them as passive methods and active methods. When we talk about the passive methods, they are the gravity methods, the magnetic methods. It measures the natural fields. What is the deviation from these natural fields? What can we say about it? Okay, but when you talk about active method, you have to send signal into the subsurface. Okay, and you then measure variation in this physical properties. So our active methods is the electrical methods, the seismic method, the ground penetrating radar. All these are active methods. Likewise, the contact methods and the non-contact methods. The passive methods, they are the non-contact methods. You don't have to have your source and your receiver having contact with the ground, okay? Like your magnet, like your gravity, okay? But your active method, your source and your receiver, they are usually on the ground. So that is the contact method. So these parameters, these methods, what do they measure? Your density. Your gravity measures density. Your magnetic method measures magnetic susceptibility. So what does it measure? It measures the amount of magnetization in the subsurface. So which data can help you in exploring for your hull. Okay? Then you have the propagation velocity. What methods measure propagation in velocity? That is seismic. Okay? Then we talk about resistivity and induced polarization. That one talks about conductivity, injecting current into the subsurface, and it resists the flow of the current. Okay, So that could be used for groundwater investigation. It could be used for engineering. It could be used for contamination studies. We have accept potential, which is still electrical methods. Then we have also the electric method, which could also be used for discovery of. Okay, this is an example of the gravimeter. So our gravimeter for measuring the density contrast. We have the magnetic susceptibility meter. Then we have a-bend parameter. That's resistivity meter. That's used for electrical survey. So you can see that we have the electrodes, we have the cables, we have the wheels for the cable that are used in connecting to all these equipment. So seismic methods, particular seismic reflection, provide detailed information about the subsurface. So electrical methods are well suited to tracking the subsurface water table, locating water-bearing sands, and also seismic methods could also be used for that purpose. So this is a model, a 2D subsurface model generated from electrical methods. Okay, and you can see our interpretation. What is being measured is an ohm meter. That is resistivity value. Okay, and this can help us in discriminating where we have saturated sand, unsaturated sand. I told you the electrical method could be used for groundwater study. Okay, so and it could also be for engineering investigation. For instance, you can see saturated clay soil. That means this kind of region is not good for siting, for building. So if you want to build, look at where it is competent. Okay, and this is infield. This saturated clay. You know, when you see the subsurface, it cannot inform you what can be done to improve the competency of that layer to suit whatever structure that you want to put into place. So one method could be used for more than one purposes. Okay, so for instance, your gravity method that measures density. What can you use it for? Is number one. It can be used for hydrocarbon exploration. It can be used for number two, which is regional geological studies. So your gravity method could be used for hydrocarbon exploration. It could be used for regional geological studies, and it could be used for other methods too. These are the primary methods that it will be used for. It could also be used for these purposes too, for exploration of minerals, for engineering site investigation, for hydrogeological investigation, and so on and so forth. Okay? So you can see your magnetic method, which is number two. What can you use your magnetic method for? You can use it for hydrocarbon exploration, regional geological studies, exploration of mineral deposits. So you can see it there, what they can be used for. And as it proceeds, you see what different methods can be used for. I told you that the first thing that you need to do is measurement. Going to the field to acquire data. After you have acquired data, the next stage is data processing. You get your software, you input your data, you process it. You now generate the model, just like I showed you for the 2D, which you now interpret. That's interpretation. Measurement, data acquisition, data processing, and interpretation. And when you talk about your interpretation could be quantitative or qualitative. Quantitative in the sense that it involves numerical values. Compute, you estimate. Then when you talk about your qualitative, that is a look analysis. You generate your graphs, you generate your plots, and you interpret. Okay? Now, when you want to go to the field, to acquire data, the design, you have to have a plan. How to generate a map of the field. Okay? What is the extent? What is the area extent? Okay? If I want to acquire my data, I have to acquire my data along a straight line. You have to establish your straight line Okay, you have to establish your transverses. We call it transverses. So it's along that line that you must place your equipment and you acquire your data. And you use different methods along same line, taking various measurements, and you take your coordinates with the use of your GPS. You take your coordinates at every point. And these are vital information because you use it to generate your map. Okay? So planning a geophysical survey. So first of all, you must have a target. Why are you going to the field? Why do you want to go and acquire the data? Is it for hydrocarbon exploration? Is it for groundwater investigation? Is it for engineering investigation? Why are you going to the field to go and acquire the data? That is the objective. It's very, very important. It's very, very genuine because that is going to determine the kind of method. Okay. Then another thing is the environment. Is it a sedimentary environment? Is it a basement complex? What kind of geophysical method is applicable for a basement complex? What kind of geophysical method is applicable for a sedimentary environment? So that will inform the kind of that you want to use in order to investigate, maybe for groundwater, or investigate for engineering, or investigate for groundwater contamination, and so on and so forth. So your survey objective, then your budget. You want to go and acquire data in Imo State. You have to think of, how am I going to move my equipment to the Imo State? How many days am I going to be on the field to acquire the data? What is the scope of the project I'm going for? Am I going to be there for a month? Am I going to acquire on the field for a month? How many personnel am I going to work with? I'm going to put them in hotel, the logistics. The hotel they're going to stay for 30 days. So you have to have your budget. How are you going to move your equipment? How are you going to be charging your equipment? You have to put all that into consideration. What geophysical method do you want to use? What geophysical equipment are you going to hire? How much is the cost of the equipment per day? If I want to use it for 30 days, how much is it going to cost me? The personnel I'm going to work with, I'm going to pay them per day. I'm working with 4 people, I'll pay them per day. How much am I going to pay them per day? You calculate. So you have to have your budget. Then when you acquire your data, you have to have a storage unit where you store your data. So that after you have acquired your data, you retrieve the data, okay? And the data will now be loaded into the software that will be processed. And from there, you'll be able to generate your subsurface model, which you now interpret. So the cost will depend on where is the survey to take place, how can you reach the proposed field site, what is the scale of the survey, what is the kind of equipment that you want to use, and the various logistics, which I've talked about. So this is talking about, you can see here, talking about your anomaly. You can see where you have the highest amplitude, deviation from the normal trend. Okay, that is talking about your interpretation now. Okay, so you can see the normal trend. Okay, and you cannot see where you have your anomaly. And when you have anomaly, there must be a factor causing the anomaly. Maybe because of the kind of structure that you have at that subsurface. That is why you're having that kind of response. Okay, and like I said, where do you carry out your survey? You can carry it on land, air, sea, space, and so on and so forth. I believe that you have thought about how to space, how to acquire your data, how to do your spacing so that you don't miss out information. That has been taken part, that aspect has been taken by Dr. Allo, I want to presume. True or false? No response? Hmm? I'm waiting. I said that aspect has been taken by Dr. Alo. How to do your spacing, how to improve your signal to noise ratio, how to improve the quality of your data, but the kind of filter that you apply to improve the quality of your data. Because if your data is noisy, it's going to affect your interpretation. I said for your interpretation, that firstly, you talk about your measurement, that's data acquisition. You talk about your data processing using the use of software. Then you talk about generating the model, which you now interpret. And I said for your interpretation, we have a quantitative interpretation and we have qualitative interpretation. And I said the quantitative interpretation deals with numerical values, you estimate, you calculate, you use numerical values to quote. But when you talk about your quick look analysis, you can interpret just from your graph, you can interpret. It doesn't necessarily have to do with numerical values. Okay, and your qualitative analysis will also be called the quick look analysis. So that is why we use all this color legend that can quickly help you in interpreting. Okay, so for qualitative interpretation of geophysical map begins with visual inspection of the shape and trend of the major anomalies. So the contour pattern can give you an idea of what is happening. Okay, just like we have here, you identify the top of the sounds, you identify the structures that we have there that can help you. Okay, we also talk about the borehole data. I told you that when you drill, you retrieve sample, okay, and that sample can give us information. Likewise, we know there's an aspect of geophysics called borehole logging. Borehole logging in the sense that after the hole has been drilled, certain measurements could also be taken along the borehole. And this measurement could also help us in our interpretation. So when you talk about borehole logging, it's a detailed, continuous measurement along the borehole at every varying depth. So information is being digitized. So we can measure along the borehole what is the level of radioactivity. Okay, and when you talk about this measurement of radioactivity, it has to do with the constituents of the formation there. What is the amount of the thorium, uranium, and potassium that we have along this formation? Because they are highly radioactive. And if they are radioactive, it can help us in discriminating the lithologies that we have there. Is it clay? Is it shale? Is it sand? Is it sandy clay? So we can take this measurement of this radiation and it can give us idea of the kind of lithologies that we have at the subsurface. We can see the depths at varying depths, and we can see variation in the lithologies that we have here. You can see here, around 250 to 300, we have sand. Around 300 to 310, we have clay. Around 310 to we have sand. Okay, and we have silt air. So you can see, and you can see the particles being retrieved. Okay, this is the interpretation. This is the sample that has been retrieved and which has now been correlated with the borehole data to confirm the interpretation. And this is also a measurement taken along the borehole, measuring the resistivity. Electric current is being set into the subsurface and the resistance, the resistivity is being measured, and that is what is being digitized there. Okay, and that can help us in discriminating our fluid type. Our resistivity can help us in discriminating our fluid type. That is, when you have a saline water, the conductivity will be high. And if conductivity is high, that means resistivity is low because they are inversely proportional. Okay, so that can help us in discriminating the fluid that we have in the formation. Now, is it a saline fluid? Is it a fresh fluid? Is it hydrocarbon? Hydrocarbon tends to be to behave like insulator, okay, because they are from remains, decay of remains of plants, animals, or buried under pressure, great heat for so many years. Okay, so it tends to have high resistivity. Okay, but if it is fresh water is not as conductive as the saline water. So in areas where we have saltwater intrusion, our resistivity methods can help us in discriminating where we have fresh water and where we have contaminated water. Okay, and it could also help us in identifying where we have our hydrocarbon. So this, for instance, like I said, that when you talk about interpretation, that we could have quantitative interpretation and we could have qualitative. So this is an example of quantitative because it has to do with estimating. Okay, and these are parameters that will determine under hydrocarbon perspective. We call it petrophysics. These are some of the parameters that you estimate, to determine the quality of the reservoir. Limitations of geophysical methods. Methods require contrast in physical properties. If there's no contrast in physical properties, then there's nothing to measure. If there's no anomaly, it will just give you the normal trend. So, and it's not giving you any clue. So non-uniqueness. Non-uniqueness in the sense that one method can give you several interpretations. Okay? And for you to be able to narrow it down, that is why you have to use more than one method. And you have to set your objective. What is your target? Why are you going out on field for investigation? So you have to set your target. You have to know the geology of that environment. And your borehole data is also very important, which you use in validating your interpretation. Yes, resolution, depth of penetration. For you to be able to penetrate deep, we use the contact method. And you usually have better resolution. But we also use the non-contact method for our recognizance survey because it enables us to cover large expanse of area. It does not require so much personnel, okay? And it can now give us idea of where to concentrate so that we can be able to get detailed information, okay? Noise prevents recovery of low amplitude, your signal to noise ratio. While acquiring data, you must ensure that you avoid all those noise, cultural noise, man-made noise, so as to have good quality data. Because if your data is noisy, then your interpretation will be wrong. And you apply all sorts of filter to improve the signal to noise ratio. Okay, several geophysical surveying methods can be used at sea. Aerogeophysics. Okay, the reconnaissance surveys are often carried out from the air because of the high speed of operation. In such cases, the electrical assessment methods are not applicable. So since these are required, so geophysical methods are often used in combination. You don't use it in isolation. You use it in combination because that is the way you can have confidence in your interpretation. Your data acquisition, just like I said, is a grid line for your seismic survey. So you can see how the data is being acquired. So like I said, that it could be acquired on water, it could be acquired on land, and so on. And this is an example of a qualitative interpretation. Okay? You can see the model being generated, the model of the subsurface, and you can see giving color, the color, to give you a quick look analysis. So the legend could tell you that the region where we have, that the region where you have your red indicates where you have your hydrocarbon prospect. And where you have your blue is where you don't have any hydrocarbon accumulation. So you can see it has given you a model of the subsurface, and you can quickly interpret that these are the region that if you want to drill, this is the kind of region where the well should be placed. These regions are not the promising zone. So that is what your geophysical method can do for you. So they are used in combination. For example, the search for metalliferous mineral deposits often utilizes airborne magnetic and electromagnetic surveying. So, like different methods have their areas of specialty, what they are meant for, and what they are used for. For prospecting for oil, you use your gravity, you use your magnetic, you use your seismic method. So you can see that we have to combine these methods together because the limit of one method is being compensated by another method. So the airborne geophysical methods are used in reconnaissance work, but the ground methods are used in more detailed investigations. The airborne, they are fast, they are relatively inexpensive, okay? Several kinds of survey can be done at once. They can provide a more objective coverage than ground surveys in many kinds of terrain. You know, at times you might not have accessibility to some areas, okay? So using the airborne platform gives you the privilege to be able to survey the area and be able to get data that can be very useful. Several hundred line kilometers to be surveyed, okay? So the cost of airborne electromagnetic survey with magnetic radiometric data is not so expensive. So airborne survey patterns are reasonably uniform and complete, but they do not have access and transit problem and all that. You know, but if you want to get high resolution, depth of penetration, our contact methods are very, very important. So we use the non-contact method also with the contact methods. So this for gravity anomaly, soft dome, okay? The magnetic methods are related to changes of structures, magnetic susceptibility in certain near surface rocks. The magnetic surveys are designed to map structure on or inside the basement rocks or to detect magnetic mineral directly. So that can be used in mining exploration. Okay, mining of lithium, mining of all this ore. Okay, so our magnetic methods will be useful in this area. Intrusive bodies such as dikes can often be distinguished on the basis of magnetic observations. So you should know what your magnetic method. Your magnetic method could be used in ore exploration. Okay, electrical methods. You know, we have talked about that we can use our electrical resistivity method. We can use it for engineering investigation, for groundwater studies, contaminant studies. It is very useful in all those areas. So that is well logging. That I talk about radioactivity, emission of this gamma ray from the log, and which can help us in delineating our lithologies. This involves probing the earth with instruments which give continuous reading recorded at the surface as they are lowered into the boreholes. Okay, they are usually used for groundwater. They can be used for groundwater investigation. They are also used for hydrocarbon exploration. They are used for hydrocarbon exploration. The rock properties which are covered by well logging techniques and samples are taken, core samples are taken from this well, and they are taken into the lab for further analysis, which gives confidence in interpretation. So well logging is one of the most widely used of all the physical techniques, and it's very expensive. It's very expensive because it's the direct method. You take the sample, you can see the sample, you can analyze the sample. While geophysical methods inferred, but our borehole data will retrieve the sample, and the core sample can be taken into the lab for analysis and for measurements. So that is why it is usually used to validate our log data, to validate our interpretation. So I don't know if there's any question. Any question? Any question? Is there any question? You have gone for it's 2 o'clock. Your practical is 2 o'clock. Any question? Nobody is responding. I did you. Hear me this? Any question? No question. Hmm? When can we have the second class? Is tomorrow a good time? Hmm? Adedeji, are you not there? I'm listening.
I'm here, ma.
Yes. The second aspect. When can we have the class? So I'll give you the slide. When can we have the class? Is tomorrow visible? Hmm? Is tomorrow visible? You guys will respond now. I don't understand that you're not responding. Hmm? Okay. I'll generate link for the second class. Probably tomorrow. I'll discuss with the class rep so that we can call it a day.